We present Dancing Under the Stars, Video Denoising in Starlight. The best cameras on the market today need moonlight illumination to capture videos with motion at night. If the moon is not out, there is too little light and longer exposure times are needed, precluding the capture of motion. So today, cameras can easily capture motion in daylight all the way through moonlight illumination. But in our work, we push this limit, demonstrating video denoising by the light of only the stars, or sub-millilux levels of illumination for the first time. To do this, we take a very good camera with large pixels, a great lens, and near-infrared sensitivity, and push it to its limits, setting the camera at its highest gain, where each pixel is as sensitive to light as possible. At these settings, we can see motion by the light of the stars, but it's extremely noisy. If we contrast stretch the images, we can see more details, but the details are obstructed by the highly structured noise. Most video denoisers assume Gaussian noise, which fails on this structured noise, as we can see here. Some low-light photography projects in the past have shown very promising results by taking an experimental dataset of real, noisy, and noiseless photos and then training a denoiser specifically for low-light noise. However, we don't want to do frame-by-frame denoising. We want to do full video denoising where we leverage information across several frames to maximize our signal and produce the best video results. However, this approach doesn't work so well for video denoising, where it's difficult to obtain real motion-aligned noisy and noiseless clips for training. Since we cannot obtain an aligned dataset of real noisy and noiseless videos with ground truth, we aim to come up with a very good noise model and then use this to train our denoiser with synthetic noisy videos. But how can we generate realistic noise? Our noise is hard to quantify. It doesn't look like Gaussian noise, and existing low-light noise models don't represent this noise very well. Instead, using a small, easy-to-acquire dataset of low-gain, high-gain still images from our camera, we train a generative adversarial network to synthesize realistic noise from our camera. We constrain our generator to learn a few important parameters that are common for low-light noise, learning from data several key statistical parameters of the noise. This keeps our noise model interpretable and easy to train. After training, our noise generator produces realistic noise. We can then use this noise generator to train our video denoiser with synthetic video clips as well as real noisy and noiseless still images from our camera, using all the data that we have to our advantage. Here's an example still image from our dataset. Traditional denoisers fail on this data. Our method produces the most detail, closely matching the ground truth and preserving high-frequency information. The real test of our method is its performance on sub-millilux videos with lots of motion in the darkest settings. Here we can see our result, achieving good denoising performance. We have high enough frame rates to see the flags blowing in the wind, along with fast-moving shooting stars, as you see on the top right, and slow-moving satellites across the night sky. Here's another example. With our method, we can see the motion as well as the Milky Way in the sky. Here's a compilation of a few denoised videos from our dataset, where we can see lots of motion and dancing by the light of the stars alone. Please check out our project page and dataset for more videos and information. Thank you.